Have you ever wondered what lies inside a black hole? These cosmic beasts devour everything around them: light, matter, even space, and time itself. For decades, they were the universe's greatest mystery, feared and misunderstood. But now, with advances in science, we're beginning to uncover their secrets. This isn't science fiction. These are real theories, rooted in Einstein's equations, sharpened by Stephen Hawking's mind, and tested by telescopes peering into the abyss. So today, we dive into the unknown, past the event horizon, into the heart of darkness. And we ask the ultimate question: what's really inside a black hole? At the very center of a black hole lies something so extreme, it breaks reality: the singularity. This is a point where gravity becomes infinite, where all matter is crushed to a size of zero. Time doesn't just slow down here, it might stop entirely. Space loses all meaning. Directions cease to exist. Einstein's equations predict this singularity, but they also scream that our current physics can't handle it. It's a glitch in the universe, a place where logic, math, and even language fail. We can't see the singularity. We can't reach it. But the math tells us it's real, but beyond comprehension, like trying to explain color to someone who's never seen light. It's the edge of understanding and maybe the birthplace of something deeper we haven't yet discovered. Inside a black hole, time and space don't play by the usual rules. They switch roles. Time becomes the direction you move, and you can't stop. You're pulled not just forward in space, but forward in time, toward the singularity. There's no way to turn around, no way to hover. To an outside observer, you'd look frozen at the edge, never crossing. But to you, from your perspective, you fall right through the event horizon. No alarms, no signs, just a one-way trip forward. Inside, space isn't just distorted, it's rewritten. You're not just in a black hole, you're in a new kind of reality, one where time is your prison, and the future is unavoidable. So what happens to anything that falls in? A star, a planet, you? According to general relativity, it's crushed out of existence. But quantum mechanics, our theory of the very small, says no information can ever be truly destroyed. This creates a contradiction, the infamous information paradox. Stephen Hawking proposed that black holes emit tiny amounts of energy, called Hawking radiation. Over unimaginable time, they could evaporate entirely. But if the black hole disappears, where does everything it swallowed go? Is the information gone forever? Does it leak back out, or get encoded somehow in the radiation? No one knows the answer. And until we do, this paradox remains one of the deepest mysteries in modern physics, where two of our greatest theories clash. Let's say you're on a spaceship, falling straight into a black hole. What would it feel like? As you approach the event horizon, gravity gets stronger at your feet than at your head. You stretch, then stretch more. Your body turns into a long, thin strand, like spaghetti. Scientists literally call it spaghettification. If it's a small black hole, the stretching would be instant and violent. You'd be torn apart. But in a supermassive black hole, like the one at the center of our galaxy, the tidal forces at the horizon are surprisingly gentle. You might pass through it without feeling anything at all. But once inside, there's no going back. You drift helplessly inward, space and time guiding you toward the singularity. Behind you, the universe speeds up. You might see stars racing past, galaxies swirling, time bending. And ahead, only darkness, only mystery, only the unknown. Here's where things stop being science fiction and start being speculative science. What if a black hole isn't the end of everything but a doorway to somewhere else? Some of the boldest theories in modern physics suggest just that. What looks like destruction from the outside, matter vanishing forever, might actually be a kind of transition, not an end, but a passage. Let's start with the idea of wormholes. These are theoretical tunnels through spacetime, shortcuts that could connect to distant regions of the universe. Picture space as a sheet of paper. If you fold the paper and punch a hole through it, a wormhole would connect those two points instantly. Some scientists believe that under extreme conditions, like inside a black hole, a wormhole might naturally form. Now imagine this: you fall into a black hole here in the Milky Way, and come out somewhere else in the universe, or even in a different universe altogether. Sound impossible? Well, here's the wild part: the math doesn't forbid it. Einstein's equations allow for solutions where black holes can be bridges, Einstein-Rosen bridges, between two regions of spacetime. But there's a catch: these bridges are incredibly unstable. They collapse faster than light can cross them, unless something holds them open. And that something would need to be exotic matter with negative energy, something we've never observed. Still, the idea persists, because black holes are already extreme, so maybe they hide extreme possibilities. Another idea takes it further. Maybe when matter collapses into a black hole, it doesn't just vanish or pass through a tunnel. Maybe it rebounds in another realm. Some physicists propose that every black hole might contain the seed of a new universe. When spacetime bends and folds under that much pressure, it might bounce, like a trampoline snapping back, forming an entirely new spacetime inside. Think about that. What looks like an ending, a collapse, could be the birth of a cosmos. Your black hole might be someone else's Big Bang. In this model, our own universe could be the interior of a black hole from some larger universe. A universe inside a universe, a cosmic Russian doll. And inside our black holes, maybe the same thing is happening: new universes forming, expanding, evolving. Each black hole a creator, not a destroyer. We don't know if this is true. We can't observe what's inside. We can't send probes. Even light can't escape to tell the story. But in physics, when the math hints at something profound, even if it's undetectable now, we listen, we imagine, we push the boundaries. And black holes push those boundaries harder than anything else in the cosmos. They're not just monsters that devour stars. They might be gateways, mirrors, or mothers of entire new realities. Maybe that's why we're so fascinated by them, because they sit at the intersection of destruction and creation, of science and speculation, of what we know and what we can't even begin to guess. So, is a black hole a portal? We can't answer yet, but if it is, then falling into one isn't the end of your journey. It's the start of something unimaginable, a voyage to somewhere, or something, beyond space, time, and even understanding. Are black holes eternal? Not quite. In the 1970s, Stephen Hawking made a discovery that shocked the scientific world. Black holes aren't completely black. They actually glow, not brightly, not like stars, but they emit a faint thermal radiation, now known as Hawking radiation. This radiation isn't emitted from inside the black hole. It comes from the edges, from the quantum chaos at the event horizon. Particles and antiparticles constantly pop into existence in empty space, then annihilate each other almost instantly. But if this happens right at the edge of a black hole, one of these particles might fall in while the other escapes. To an outside observer, it looks like the black hole is slowly leaking energy. And that's exactly what it is. Evaporation. Over incomprehensibly long timescales, we're talking 10 years or more for the supermassive ones, black holes shrink. They lose mass. They get smaller and hotter. The smaller they get, the more intense the radiation becomes. Eventually, they reach a critical point. In their final moments, they blaze with energy, hotter than a billion suns, and then vanish in a violent burst. Gone. No trace left. But what happens to all the information they swallowed? Everything that ever fell in, stars, planets, atoms, the quantum states of particles, was it all destroyed? That's where the information paradox comes back with a vengeance. Because according to quantum mechanics, information can't be lost. The universe must always keep a record, even if scrambled beyond recognition. But if a black hole disappears entirely, where's the record? This isn't a trivial question. It's a showdown between two of our most powerful theories: general relativity, which says information is lost; quantum theory, which says it's not. Both can't be right. And until we figure out which one breaks down, or how to make them work together, we can't truly understand the nature of reality. Some physicists propose that the information leaks out slowly, encoded in the Hawking radiation. Others say the event horizon stores it like a cosmic hologram, projected on the surface, a bizarre idea called the holographic principle. Still others imagine that black holes don't evaporate completely. Maybe something is left behind, like a stable remnant, but we don't know. We have no way to observe this radiation directly. Black holes are too far, too cold, too quiet. So for now, we wait, we theorize, we simulate, and maybe, someday, we'll detect the death cry of a black hole, and with it, the final clue to the deepest mystery in the universe. So, after all of this, what is inside a black hole? A singularity, a wormhole, a baby universe, or absolutely nothing? We've aimed our best science at the question: telescopes, satellites, equations, but the answer remains hidden. Maybe that's the point. Black holes aren't just objects. They're mysteries, where our deepest theories break down, where space and time blur, where quantum mechanics and relativity collide. Inside, time twists, causality can shatter. Even the idea of inside stops making sense. And yet, we know they exist. We've seen stars dance around them, heard their collisions through gravitational waves. We've even photographed their shadow, a ring of fire around the unknown. But what's beyond that ring? No one knows. A boundary we can't cross, a question we can't yet answer. Maybe the real question isn't what's in there, but what does it say about us? Because to study black holes is to chase the limits of knowledge, and maybe to glimpse what's beyond.